Everybody, on the sixth lecture concerning Java. I hope that you can hear me and that you see slides. Could somebody confirm?
Yes, we can. Good morning.
Okay, thank you very much. Okay, on one hand, we had fortunately finished synchronization because it was not an easy task. On the other hand, of course, some elements of synchronization will be used in some examples shown by me today. Um, the subject for today is network programming. So I will go through some classes that we can find in Java that help us to do some networking. Okay, so opening TCP or more high level connections between a client and the server. Okay, so uh, let's say I assume that you have some background on networks. Okay, of course, I will try to explain some details how to program. Okay, so um since I'm not really sure what is your background, okay, this is not a lecture on networking, on networks. Okay, I'm not an expert in that area. I'm the user of network for many years. Uh, and I remember times that there was no TCP/IP at our university. Okay, so I remember not the beginning of TCP/IP because it's a quite old standard, but I remember when it was introduced. So the beginning of internet that is based mostly on TCP/IP connection. So what is important here, and you should have this knowledge that to work with networks, we see the network by layers. Okay, so some abstractions that allow us to uh, do the stuff. I mean, do programming and do connections. Okay, so of course I will mostly focus here on these three upper layers of the TCP/IP. I mean the application layer. So we'll talk something about HTTP as the most popular connections. I will show you how to establish such connection inside Java. Okay. Of course, this is based on the transport layer, so TCP and UDP differences and how we open connections. And of course, this is connected with the network layer, so the IPs. I will not talk anything on the link layer because this is on the level of the operating system. So I will talk about these three upper layers of TCP/IP. Okay, so the first information that you should be familiar with as students, but also as users of the internet, is the idea of IP address. This is technically speaking a 32-bit number. Okay, it consists of 4 8 bits. Okay, so the most common representation is using the deaded dot notation. Okay, so we have numbers in digits, in decimal digits, of course. So from 0 to 55. Okay, but technically speaking, this is a 32-bit number. Okay, so 4 8s. Okay, 4 bytes. Uh, I hope that you know that address 217.0.0.1 is refers to the current machine. Okay, so this is a custom that we are using from the beginning of internet, and its name is localhost. So whenever you refer to localhost or that address, it will connect with your own computer. But of course, you know that computer could have many different IPs. Okay, so uh, of course, the most typical situation is that we have one IP. However, nowadays, when we have Dockers and other stuff installed on our computers, so you can run ipconfig or ifconfig, depending if it's Linux or Windows, and you can notice how many IPs we have. So, okay, maybe I will not switch, but just do it on your computer. So write down ipconfig and see how many networks you have. Uh, Okay, so what else is important to understand the coding that will be on next slides? Okay, so each computer is not a true. So each endpoint has an IP address. Okay, and we have DNSs, which I know you are aware of. That so an IP address, which is a number, so it's hard for humans to be read, could be represented by different strings. Okay, and DNS is a conversion from the string like that to the IP address, which is a number. And and of course, it works well for the public IPs that are available in the public DNS. Okay. What else is important to understand is the idea of datagram. Okay. So the data are sent by packets. Okay. So they are called datagrams, and they are of a limited size. Okay. So on the logical level, this is up to 65 kilobytes. Okay, but when we think about Ethernet network, it's only 1,500 bytes. Okay, so really the IP protocol, which is an element of the most common network TCP/IP protocol, defines how datagrams are sent across the network. So we have the routing problems between machines, of course, because we are not directly connected with anything. We are always mostly connected with one router. Of course, it could be different, but on our let's say private computers, it's mostly that we are connected with one router that goes to the routers and goes to the other router. Okay, but we don't have to take care on it. It's working. Okay, this is not a problem of programming. It is the problem of networking, and this is not the aim of our lecture. But what is important to understand what we are talking about and see the differences and when which should be used is that the IP is an unreliable protocol. Okay, so it's the IP could be seen as sending some packets. Okay, so or sending. So we have trains, we have I don't know cars that transport some data, and we have the source address and the destination address, and as in reality something bad could happen. I mean, the data could be lost. Okay, so take into consideration that IP protocol is not reliable. Okay, it means that datagrams that are sent may be lost, that could arrive out of order. Okay, so we will send one datagram, then the next one, the third, the fourth, and on the end point they could come in a different direction because they could select different routes and something bad could happen. Okay, or even they could be duplicated. So this is a very low level, but sometimes useful, and we will talk about it when it is useful. Okay, so if we want to connect two computers, okay, or even if you connect two processes, two programs over a network, it is based on TCP or UDP. Okay? Or really, TCP is using UDP as the IP protocol as the lower level, but this is something that behaves slightly differently. Okay, so the TCP transmission control protocol and UDP user datagram protocol. Okay, so as you can see from the name, UDP is more directly connected with the IP network layer and uses datagrams. Okay, mostly, strictly speaking, we are using application layers. Okay, so we are using implementation of some protocol on the TCP/IP. This is the most typical situation. But if some protocol which is rare is not implemented, it is mostly easy to be implemented since we have a TCP capabilities inside Java. Okay, so HTTP, which is a protocol for sending some data through internet. I mean, you are uploading the HTML web page using HTTP. It's very simple. It's a text-based protocol. We are establishing TCP connection, and there are a few comments like get and the name, the local path, and also some headers which are just strings So we have the name of the field, double dots, the value, enter, and the next header. Okay, so this is a really simple protocol, by the way. Okay, of course, it is implemented as a class, but we have really infinite number of protocols. So if it's not available, you can do it by hand, since the low-level features, I mean TCP/IP connections, are available. Of course, some of the protocols are using UDP. Okay, and I will try to show you what is the difference between them and when use TCP and when use UDP. Okay, so TCP, which is the most common used protocol, TCP/IP protocol. Okay, so even it exists inside the name, is connection based. So on contrary to the lower level, which is the network level, IP, so datagrams, it is reliable. Okay, so it constructs an abstract of bidirectional flow. Okay, so we have a pipe from me to you and a pipe from you to me. Okay, so we can establish a pipe, and whatever is stored in the pipe on one side could be taken from the other side. Of course, it is based on the lower level, on the datagrams. So the data are stored into that cars transport through the network, and they could be lost. But TCP, which is implemented inside your operating system, gives the guarantee that everything will be okay. I mean that if something will be lost, the data automatically resend. You don't have to do it by yourself. Okay, and orders of data, orders of packets are checked on the receiving end, and so if something is missing, the endpoint is waiting to for that missing element. Okay, so TCP/IP is an abstraction which looks like a pipe, but of course is based on the lower level elements, that packages, that IP datagrams that are sent. Okay, this is the idea of really network, that we have layers, which from the functionality behaves differently, but they are interconnected. But it's like in a reality. Okay, we see the biology, which is based on the chemistry, which is based on the physics, it's low-level physics. But to be a biologist, you don't have to be expertise in quarks, for example, which really has the influence. But each layer somehow hides what is behind. Okay, and it's more or less is the same. So TCP/IP is based on IP, of course. It's using IP, but in more abstract way. So you don't have to take care about losses of packets. You don't have to take care about orders. It's done by automatically. But of course, something really bad could happen. So the TCP/IP connection could be broken, and it will be, as you, I hope, expect, seen for the programmer by exceptions. Okay, this is the tool that we are using as programmers to deal with some unexpected situations. Okay, and mostly or very often, a lot of application layer protocols are based on the TCP/IP. So the most common HTTP, FTP protocols are based on TCP. UDP, which is using directly the datagrams. So this is, it could be seen on somehow as a low level, but it's not. It's on the same layer. So what's the difference? Here, the abstractions are datagrams. So we have some boxes that are filled with data, some parcels, okay, with the source address and destination address, and they are sent, and that's all. So UDP does not guarantee that data will arrive at the destination in the same order in which it was sent. Okay. Really, UDP does not guarantee that the data will arrive at the destination at all. So UDP is not connection-based. TCP is connection-based. Okay, so why to use such unreliable protocol? Because it is faster, in that sense that you don't have that over load caused by resending data, by error connections, etc. So in case if you have applications that do not require or that require fast data transfer, but do not require 100% reliability, we are using UDP. So for example, video and audio streaming is very often based on UDP because it's more important that to have online connection, okay, than just, but if you lost one frame, okay, maybe you lost a piece of my voice, okay, but it's more important that you will hear me online than to have a delay, okay. Other example are as a time servers, so we have a protocol that allows you to synchronize computers, okay. It's quite important because a lot of functionalities of applications is based on the time, okay. So we have a server that is capable of sending the current time, okay. So if some datagram will be lost, okay, maybe the synchronization of your computer for 1 second will be not done, but probably during 1 second, the difference caused by your not perfect clock on your computer is not very big. Okay, so more important is to get the current time to be and to get it in as short time as possible than just the problem caused by losing some packages. Or I think the most common functionalities connected with network and the protocol used by, I hope, everybody. I was using it today because I have some problems with connections with the university. I think one of the border router has some problems, and it was really confirmed because I got information that today, late evening or in the middle of night, the university will be cut off from the internet for 1 hour. Okay, so probably they have some problems. And I was pinging to the nearest university computer, and I noticed that some data are lost. So it is information that, and the pings were with different times. So it showed me this is not my local problem, but the problem with the internet at university. But ping, we have such comment in Unix, Windows, okay, that use that ping protocol is based on UDP, right? Because we are just sending packets, and if they lost, they are lost. Okay, this is a way how we can test what's going on with the internet. Okay, so maybe UDP is not so often used as TCP for connections, but it is still used, and such capabilities we have inside Java. Okay, so what else we have to understand to understand the code which will be shown by me is the idea of sockets and ports. It's quite important idea. It's of course an abstraction. And it is connected with TCP, but also with UDP. We have a separate area of TCP ports and UDP ports. Okay, so endpoints, because I told you that TCP connection could be seen as a pipe. Okay, so we have two ends. Okay, and they are called sockets. This is the name. Okay, socket is the name of the end of the TCP/IP connection. To make it working, we could have only one socket on a particular port on a particular machine. Okay, so if I want to connect with somebody, with anything, I need to have a IP, okay, and I need to have a port, okay, because having them both allows me to establish a TCP/IP socket. So socket has two features, so the IP and the port number. Ports are identified via 16-bit integers. We are talking about TCP/IP4, not the newest one, okay? So integers between 0 and maximum number 16-bit number. So it is really a limit, okay, because it limits the number of simultaneous connections from one side to the other, okay, because each connection has to be done on a different port. And we have some customs. I mean, mostly the first 10 bits are used for the common services. Okay, for example, HTTP is mostly listening on port 80. Of course, it could be any port, but if you put HTTP in your web browsers and you will not add a port number to the protocol, to the IP, by default 80 will be assumed, okay? For example, FTP is mostly working on ports 20 and 21. SMTP, simple mail protocol, so the protocol connected with emails, is 25. But for example, HTTPS, so the secured HTTP with encryption is by default 443. But of course, it could be anything. In Unix systems, okay, so like Linux, for example, to open a port being a server, so this endpoint, the other side of the pipe, opening something, listening on the port less than 1024 requires you a root privileges, okay? So if you want to listen on 80 port, you have to have a root privileges on your computer. And then the next range from 1024 to 49151 are so-called register ports. So this is ports that are used for other purposes, any purposes. For example, there's a custom, then 8080 is an alternative of 80 for running a web server using just not root user. Okay, so but you are free to use any free port, because be careful that on one port, on one IP, because you can have a computer with more than one IP. Okay, it's different, but for one IP and for one port, only one process could wait for a connection. Okay, so for example, if the port 8080 is used by some other process, you are unable to open it again by other process. Okay, so what will happen in a program, in a code? Of course, the exception will be raised. And the last part, dynamic or private ports are used for any other purposes. So very often we are using any ports not used for any local connections, okay? Mostly for that last part, dynamically assigned. Okay, so some more information connected with ports, because it is important to understand the code, which will be shown later on. Okay, so we have to understand the physics. Okay, this is the physics, the background of networks. So the client, and this is not the problem of Java, this is the idea of TCP/IP protocol. So when you want to open a connection, you have to know the server IP and the port. So that number between 0 to 65,000. So all data coming into a machine might enter through a single physical network connection. So this is the IP. However, due to idea of ports, it could be sent for different applications. Right? So each application that receives data is listening for the data on a specific port, And we have separate ports for TCP and separate ports UDP. So you could have two different services listening on the same port number, but using TCP or UDP. Okay, so we have also in UDP a port number associated with the application that uses the data. So on the server side, we are talking about binding to a socket. Okay, so the application, your code will bind a socket on a specific port number. And if somebody will open a connection to your host to that port, the data will be sent to your application. Okay, so data are sent on a given computer by IP, and they have inside the port number, okay, and the data. So your computer, your operating system, of course, selects which application, which process receives this data based on port numbers. So ports are very important, and only one application, one process on one port. So I've told you that we have two protocols, two mechanisms, UDP based on datagrams and TCP/IP. Which is better? Of course, it depends on the situation. In UDP, there is no connection setup time. Data just sent. Okay, so you put the destination address and you don't have to take care of anything else as you are sending data. In TCP/IP is different. At first, the TCP/IP connection has to be established. Okay, maybe it's not a long time. It's 10 to 100 milliseconds, but it's still a time. And when you have a lot of connections and usually, for example, you are assuming establishing always a new TCP/IP connection, it is costly. Okay. In UDP, we have a limit because this is the maximum size of datagram, okay, 64 kilobytes. In TCP/IP, we don't have a limit. We are establishing a pipe and sending data. Of course, technically, they go through datagrams, but we don't have to care on it. UDP is unreliable, okay, as I was talking about it a few minutes ago, where TCP is reliable. So packets are always arriving in order, but of course it is costly. If something is lost and will be resent later, so the data are waiting to be received inside your computer on your host. So TCP is useful for implementing network services such as file transfer, which require data of unknown length to be transferred, okay, or any length. UDP is less complex, more simple, has fewer overheads. It is best for implementing client-server application and distributed systems built over local area networks. Okay, so very often some protocols just for sending some data and local use UDP because it's less reliable. Okay, so I hope that after so your knowledge that you have before the lecture and after my slides, more or less, you know what is TCP or UDP. And now I will try to explain you how to use these elements using Java. So we have a set of classes connected with TCP/IP. So the class called URL, Unified Resource Locator. So the class responsible for establishing address connection with DNS is that kind of stuff. URL connection that connects using a given URL. So if in URL we have a HTTP protocol, so use HTTP anything because FTP URL and other protocols are elements of URL. And we have low level TCP classes, socket and server socket. Server socket is on the server side. So the class will be used for waiting for the connection. And when the connection will be established, then we will have sockets on both sides. Okay, so server sockets is just a blocking function waiting for a connection. And we have a set of UDP classes, okay, that are used if we are establishing UDP connections. So we have a datagram packet, so they represent the data. Okay, this is parcels. Okay, so we can store the data, and the endpoint on the other side will receive the data as datagram packet. So this is the container when the data are stored on the client side and magically through the network and operating systems are received on the endpoint. Of course, it does not require that on both sides we have Java, could be anything. But since the lecture is on Java, we will talk about Java classes. Datagram socket represents the connection, represents the datagram socket, okay? And we will talk about also a multicasting, okay? So this is connected with sending, for example, movies and that kind of stuff. I will try to explain it today, of course, but slightly later. Okay, so URL, Uniform Resource Locator. This is a standard, okay, that defines the addresses. Okay, so this is a good example of URL. The protocol, the name of the computer or the IP of the computer, and the path. Okay, so such URLs are represented in Java by the class URL. Okay, so we are using the same name, but URL is a abstract, the idea, uniform resource locator, but it's also a class that is used in Java to deal with such structures. Of course, the most often nowadays protocol, due to different reasons, HTTP or HTTPS, but of course, this is just one of many protocols, okay? FTP, SMTP, FIO, SNTP, and other things. And then we have the locator, the name of the resource, which typically, but is really depending on the protocol, consists of the host name. So this is the host name and the file name, elements of the path, optionally the port number, and some additional references, okay? Like anchors. So we are used to it because we are using URLs every day in web browsers, okay? So how to establish or create an URL in Java? It's quite simple. The class is called URL, so we are creating an object, and the argument is the string. Okay, this is the string. Okay, that represents the URL. Okay, and that's all. This is very simple. Be careful that very often URLs inside web pages are related. Okay, so if you want to parse the web page, for example, and then do the call by yourself, okay, because you want to grab some data from the internet, for example, to download automatically, analyze web pages and upload some data. This is a very typical work. And even I was doing such things on Sunday evening, but it was in Python because now I'm mostly coding in Python, but I was doing such stuff, analyzing HTML pages and doing more calls, of course. So be careful that if it's not the most common situation is to use a relative paths, so relative to the that host address. Okay, so such link from such page will go technically to such URL. So if you want to work with relative URLs, of course, you can glue the path by hand, but why to bother? we have some additional constructor that has two strings, or not, it has a URL as an argument and the relative URL as the second argument. Okay, so it builds the absolute path based on the URL and the relative URL. Okay, so I hope that now you understand why we need something like that. You can create URL from components. So we have the protocol, the host, port, path, which is the same like that. But sometimes data are coming separately. So you can do it using the URL. So this is heavy overloaded constructor with different options. The problem is that URL from the definition is not containing any special character. So for example, space is forbidden, but you know that we have spaces in addresses for many years. So it is done by escaping or encoding. So very often you can notice that we have addresses that looks like that. Okay, so the 20 is the ASCII code for the space. Okay, so we have also a URI class, which is representing uniform resource identifier, which is a more general abstract than URL that defines anything. It is not really an address. Okay, this is something that is a very abstract idea, and we can also get the URL from URI. Why it's worth? Why it's worth to do it in 2 steps, not in 1 step? Because if URL used in a URL constructor is wrong, so it's not well formatted, then the constructor throws malform exception. So if you are using URL directly, you can you have to put it in a try and catch section. A URL is a immutable object. So if you are creating it, you are unable to change its properties. Okay, so if you create it, you cannot do any changes. You have to create a new one based on the old ones, like strings. Okay, in Java. And this is the simplest way of making connections, but on one hand, the simplest from the coding point of view, but it is the most sophisticated because it uses some protocols given here. But if you want to open HTTP connection, the easiest way is just to do it. Okay, and we have a method called OpenStream that opens a connection, that establishes the connection. It returns the input stream. And this is a typical for Java stuff that we are making a new class based on the other class, okay, to play with more high-level abstracts, okay, because input stream is you have to read one character by character. When you have a buffered reader, you can read lines, for example. So this is ugly Java stuff, I would say that. Okay, that you have to do with such things, but it is quite useful and typical from Java from beginning. So it's the same when you open files and you play with anything that could be seen as a string. Okay, so that buffer reader is just used for efficiently for less coding. Okay, because you can read, for example, by lines. Okay, so without buffer reader working directly on the input stream, you will have to read byte by byte, convert them into characters. Okay, So you need to do a lot of programming, which is done automatically here, where when data are automatically converted into strings and by lines, by some chunks. So it is easier and faster. So that's why very often in Java we are doing such ugly things: opening a string, creating a new object on that string, and a second object on that string to make the coding more effective. But on the other hand, you have a long line of code. Okay. So let's look at a very simple example, okay, that just gets the main university web page. Okay. So how to do it in Java? Okay. So we have to create a URL which points to the university web page. Just notice that this is inside try and catch section because the URL could raise an exception. For example, if the address will be wrong. Next, we have open stream that opens a connection. It's again inside the try and catch because something bad could happen during opening. Okay, I don't know, the server could not respond because it's overloaded, the network is not working at your home, etc., etc. And then we are creating a buffered reader now in 2 lines. Okay, and then very simple read line, read line, read line. So as the result of that code, and of course, readline could also raise an exception because something bad could happen during reading. That's why everything is inside try and catch section. But as the result, you will see the main web page, of course, in HTML, not rendered from the screen on your console. Right? So you can notice that any popular common protocol, application protocol, is implemented here. So in the same way, you can open FTP connection, anything else what is needed. Of course, the most common situation nowadays is HTTPS protocol. Just add S, and of course, the main web page should be aware of HTTPS. I think of our university, so it will work perfectly. So this is easy, simple, and then you can do anything what you need. For example, you can grab data from the internet to do some analysis, which is a typical stuff. Okay, so let's try to summarize it to see what's going on and to see more explained code, sorry, using more informative, some more detailed exceptions, of course, because we have here there's an exception to make the code short, but really 2 exceptions could be raised by the code. Malform exception, which is connected with that line, and IO exception, which is connected with that stuff. So this is the other way how we can play with the data stuff. Okay, so using connected, because here we have been using streams, and now it's slightly different. We are using connection. It's the second possibility. Open connection obtains an object called URL connection, which is an abstract relay because a given type of a connection will be placed here depending on the protocol we have established. So for that code, we will have HTTP URL connection. Okay. So when we have a connect, then we have a connection, and we can get input stream or output stream from that connection, and then you can do it similar to the previous stuff and do what you want by hand. Okay, that URLs and URL connections are quite high level, application level mechanism. Okay, and if you are using a well-known protocol, commonly used, of course, it is a good solution. But sometimes we need to have a much more low-level communication to exchange information. Okay, and it of course has to be done somehow. So we can do it on TCP connection directly. Okay, or the other situation, we have some protocol that is not implemented in Java. It's not common protocol. So if you will not find the code, you can just do it if you have a documentation using the TCP/IP stuff. And we have them sockets, and we can just write to the socket and read from the socket, and that's all. Okay, so we have a reminding on sockets. Okay, that and remember that when we have a TCP/IP connection, sockets are on both sides. Okay, because we have a connection, we're sending data from here to here. Also, the data could be sent from the server to the client. Really, the difference between a server and a client is a difference only at the beginning. Okay, so the server is waiting for the connection, but when the connection is established, okay, we have a bidirectional connection between both sides. Okay, so client is bound automatically to some port, but it has really some port because the connection is in both directions. So how it is done in Java, we have a socket and server socket class. So socket represents sockets, okay, where a server sockets represent a socket on the server side. Okay? That socket that waits, that listens for incoming connection coming from the client. Okay? So on the socket we have during connections and during creating a connection on the client, but server socket is only connected with that part of communication which is called server. So that part of communication that is waiting for establishing the connection. Okay, so what functionality we have? Server socket has following constructors and methods, and socket has following constructors and methods. Okay, so server socket, you are on contrary to socket, you are not putting the IP, the IP address, so INET address. This is not URL. Okay, so to use TCP/IP, we will have to use special class called INET address because you are working on the local host. Okay, so your IP is defined by the place where you are. Okay, and the most important method is accept. This is a blocking method that waits for the connection, but notice what it does return. Okay, just notice that accept returns socket. So the communication is like that you are creating a socket on the client side, putting the destination address and the port number. Okay, then you will have to so it defines, and then you can get the input and output stream. Okay, on the server side, it's slightly different. You are creating server socket object, so you are stating at which port you will be listening, and this method, I'm waiting for the call. When somebody call to you, we will have socket on both sides. So just after the establishing the connection, both sides have the same object for communication, I mean sockets. And we have some additional functions that allow you to check what was the local address. I mean that INET address represents the local INET address. So what is the local port? What is the remote port? Okay, so local port on the client side, port on the server side, etc., etc. We have also methods that allows you to set timeouts because something bad could happen. So if the communication will be not established, the exception will be raised. So notice that almost all methods or constructors here on both sides are with that red asterisk. So a lot of try and catches, okay? Because I don't know, closing a connection could be a problem. Anything almost during the connections be a problem. But when the connection will be established, you will have a stream, input stream that will be output stream on the other side, because this is a pipe or two pipes. We have one pipe from the client to a server and the second pipe from the server to the client. So input stream, what will be stored in output stream on the client will be seen on the input stream on the server. So at first, we need to create a socket. Okay, so one of typical exception that could happen is an unknown host exception, because, for example, that address is wrong. Next, the socket creates a connection, the socket, so it could raise an IO exception. So we have to create a socket on the client side. When we have a socket, then using typical for Java techniques for files, but it's exactly the same as for TCP/IP connection, as streams. Okay, so since the socket is a bidirectional connection, so we have a input stream and output stream, and it's recommended that we will use for input printwriter, that's funny or ugly Java stuff, to create a new object based on the other object who has more useful classes. And I think the printwriter is the most useful. Of course, not always, depends on what are you planning to do. But if you are planning to do things which are similar to HTTP, so lines by lines and printwriter, and for output stream buffered reader, and we have been already talking about. On server, we have to do some extra work because we have to establish a server socket, and it has only one argument, the IP, the IP port, the TCP port we are listening, and then we have a blocking method, okay, accept, that waits for the connection. Until the connection will not come, the code is stopped here. And then we have a socket, which is like on the client side, the same, but everything is opposite, okay? And of course, after some communication, we should release the resources, so we should do close on socket. Okay, let's look at some examples that uses the code presented by me on the previous slide. So the first example is a port scanner. Okay, be careful with using it, because nowadays we have firewalls, so there's a big chance that your computer will be blocked, okay, because it could be treated as a kind of an attack. But if you are working locally and without any firewalls, you can run it. Do not attack university, please. Okay, or you can attack, by the way. What will be the result? If you will run such code, you will be banned for, I think, something like half an hour, okay? So there will be no way to open anything on the university site because the anti-attack software that is running on the bridge router will detect it. Okay, so be careful with that code. Okay, but it's a very simple code to check which port is open on the server side. Okay, so we are opening the socket on the given server and with selecting numbers 0, 1, 2, 3, 4, 5. Okay, so if the exception will be raised, it will mean the port is closed. If the exception will be not raised, means the port is open. So it's a simple trick that allows you to check what ports are open. Okay. Usually it was the first step in attacking, so that's why very often our nowadays computers are treating this as kind of an attack. In ancient time, nobody was attacking. Let's look in a more sophisticated example. Let's try to build a client-server communication, a kind of the chat, okay? But we will doing using threads. Why threads are important? Because without threads, we'll open a, so we'll just assume that it will be without thread, okay? So we are accepting we are waiting for the connection. When we got the connection, we have to deal with communication. So if I will not use threads, I will not call accept till I will finish the communication. So it will mean that my server is only one client capable. Okay. So servers are mostly multi-thread applications, because what is the aim of the server? Wait for the connection, deal with the connection, and dealing with the connection is done in a separate thread, okay, to allow have as much as possible connections. Okay, that's why that lecture is placed here, I mean, after multi-threading. And many elements I have shown you today, it's quite simple lecture, just facts, okay? But to use or to build a real server, threads are really needed. Because without it, just assume that you have HTTP server without multi-threading, okay? Or another trick is asynchronity, okay? But without these both tricks, it will mean that only one user could be on a page, on a server, which is stupid, okay? So that's why multi-threading is required. So how it looks like, we are creating a server socket on a given port, and the port is free, but just be aware that if the port is used by somebody else, you will have an exception, okay? Because the server socket raise an exception. So when you will test such code and you will run it twice, and the first one will be stopped, the second one will not run. Just remember that only one process could be attached to the port. So if some other process is working, so you are not allowed to reattach other process to the same port. And then we have infinity loop, because the server works for infinity. That is quite simple. Accept the connection and start a new thread that will deal with the connection. So just notice that we have a client, which is a socket object, is sent to the chat handler that deals with communication. And we have a chat handler, okay, so that stuff which is responsible for handling clients. And you notice this is runnable. Why runnable? Because we will do work with multi-threading. Okay, it has some local variables. That one will be used to store all connected elements, of course, the socket and the streams for sending and receiving data. So we are just setting the socket and okay, sorry, give me a second. I will change the, I don't know why it became so white. Originally, I planned to make it red. Maybe I have changed the default colors. Of course, we have here the synchronized word. Why? Because it could be run from different threads. Okay, so that's why we have a synchronization. Okay, so starting will get the stream with that funny Java way, okay, and starts a new thread. Okay, thread is this. And we have stop that could be called from the inside from other threads. So to prevent to do such things that we are not yet finished starting and we are stopping, we have to do synchronization on the same object. Okay, so that's why we have synchronize here. And the stop does the stuff how to stop. So exception is sent. So we are calling the interrupt on the current thread. Okay. And closing the data stream. And the main part, so the really work done by the thread, okay, because this is the run method, it was runnable, so run is the place where the code goes in, okay. So the idea is that we are registering handlers, okay, list of users, and doing stuff in an infinite loop or finite loop till somebody will stop us, okay. So we are using that flag to detect the situation that somebody wants to stop us. Okay, so we are reading data from the stream. This is the message, and we are broadcasting message to others in the same chat. Okay, this is the idea of the chat. When it will be stopped, when exception will be raised. Okay, so maybe somebody will close the connection. So this is that cause the situation. Or if somebody will stop us by thread interrupt, so the flag thread interrupted will be set up. Okay, so when we, as a thread that represents a client, the user of the chat is stopped due to different reasons, we will remove it from our list. That's all. And then we are stopping ourselves. Broadcast, okay, broadcast is that method. So we are reading and broadcasting. So what is the aim of the broadcast? Okay, and again, the broadcast is synchronized. Okay, I don't know. Sometimes it was for a second thread. I don't know what happened. So it's synchronized on handlers. Okay, because this is the object that is common. Okay, just look, this is static, so it's common for all chat handlers. Okay, so that's why it is synchronized. So I'm getting an element, going through all elements using that loop. So getting a handler and sending a data to the user. And flash is a function on that funny data stream. Okay, so that funny data stream was data output stream. It has a flash to be sure that the data are sent. If some exception will be raised, because the stream was called whatever, we are stopping our handler. And that's all. Okay, this is a very simple element that is doing the work. Now we have a client, which is a client based on with the user interface. However, the user interface will be explained by me on the next lecture. So I will come to these slides later, I mean next week, to explain you that part connected with frames, etc. Now we will focus on the functionality. And functionality is really simple. We are establishing the socket. Okay, so we have a data in and data out stream. We are making a user interface, which is not our aim to be understood today. And we are reading data and placing the data on the user interface. Okay, and that's all. Okay, so the user interface, how it's built, we'll come back to it next week. Okay, so we have TCP, but we have also datagrams, and it could be also used here. And really, very often for such things like if we want to have fast communication, maybe it's a good idea to have the chat done using datagram packets. Okay, so in UDP, we have two objects, datagram socket and datagram packet. Datagram packet is responsible for storing data. Okay, so if you want to send something, you have to create a datagram packet, put data there, okay, and send where it has to be sent. Okay, and on the other endpoint, you will get a datagram packet as the result of communication. Okay, and datagram socket that represents UDP sockets. So we have a function with port on the server side, okay, and then we can send data or receive data. Okay, so we have to connect with the client and send and receive data packets that are of such structure. Okay, so let's look how it could be done in coding. So the client side, you are creating a datagram socket. On the server side, you are creating a datagram socket and establishing with the port number, okay? Because server side is the situation that we are listening on a given port. That's why port number is required here. Okay, so if you want to send anything from the client to the server, you have to get the data somehow magically. Okay, and to prepare the datagram packet, get the address. So INET address get by name. Okay, so it allows you to have a DNS name, host name transform into the Java funny class. Okay, and then you are creating a datagram packet. So putting some data, where to send, and to which port, which of course has to be the address of the server. Okay, and that's all. It goes to anything. Okay, to that place that is defined here by that INET address. How to receive a data on the server side. Okay, so socket. Okay, so we have a socket here. Sorry, receive, and we get a data, the receive packet, which will be filled that buffer with data sent to you. Okay, it could be a bidirectional communication. So the server could now reply Okay, so we can get the port of the client, receive packet get port, and then we can prepare a datagram packet. Okay, and we have the port from here, the address from the client address, and then we can send it. So it's more low-level communication, but it is possible to be done. What's important that we have also a technique which is called a multicast. Okay, so this is the idea where we can send at once data to more than one client. Okay, this is connected with the TCP IP protocol. Okay, it has such capabilities, so we can send data to more than one client, and really it speeds up the communication. Since if of course the routers are aware of it, like routers at our university. So if some data are sent to 10 users, okay, maybe I will draw it. Okay. So for example, we have a server and we have the next router. Then we have such situation. And for example, and here we have clients. Okay, so that boxes are clients. Okay. So if the data are sent from here using multicast protocol, it goes only once to that router, then it's automatically duplicated. Okay. And here is duplicated again. But notice that this is not just sending data 3 times. You are locally sending it once, and then using multicast features of TCP/IP protocol, they are on routers automatically split it. Okay, so if each that rectangles connect to that rectangle, which is a server, join the same group, really on the first path, datagram is sent only once, so it saves the bandwidth, and it's a really good idea. So in the multicast server, we are using a dedicated range of IPs, okay, which is starting from that one, okay. So we need to know the IP address, okay, and then we can send anything to a server. Because we could have a multiple clients. So how the multicast client looks like, okay, you have to know the socket name, join the group, and then you can receive packages which are sent automatically from the server. We are joining the group. This is the idea. So the multicast socket binds to a port number given, okay, and everybody is transmitting to. Okay, so we are using the given group. So this is called multicast addresses from the group D, A, B, C, which are local addresses, and D, that area is used just only for the multicast. Okay. Of course, at the end we have to close the socket. Okay, so that's all for today. I need some break before the lab. So next time I will try to show you some ideas on the user interface. Really, on one hand, I don't want to talk about graphical user interface, native user interface, because I think this is something that is in modern times quite rare use. Because at least I don't really remember, or maybe it was 12 or 13 years ago, the last time I have built a native user interface. Mostly I'm building a user interface. Okay, I'm giving lectures, so sometimes I'm showing students how to do it, because I'm mostly in my programmer's life building a web-based user interface. So maybe so I have some doubts if I should talk to you about on one hand. On the other hand, still native user interfaces I think are common, especially for mobiles, due to some reasons. On the other hand, I think that you have to understand how, in general, user interface is built. Okay, because even if you are building a user interface on HTML, still the same idea arises. So events, event-driven programming, and how we deal with events in Java. So okay, I will, because it was planned in a curricula of our course. But really, I don't want to teach you especially, of course, it will be an example. So I will probably focus on the JavaFX, which is a modern interface in Java, modern, 20 years old. Okay, that's modern. And with all my doubts that I quite rare built a native user interface, but to understand how it is done, I have to do it. I have to understand what events means, what event-driven programming means, how to deal with events in Java. So I do not recommend you to, in the real situation, build a JavaFX application, but I think that you should build it at once, because to understand how it works. Because regardless the system you are working, still the same problem are. So there are also some problems with multi-threading. So all things will glue together, and I will comment that code that is on our today lab. So how to make a user interface based client. So how to build user interface will be the next subject. Of course, we'll not have spare labs for it, unfortunately, but is the organization of university. I think that the most clever idea will be to have half of the semester lectures and then during the next half of the semester labs. But we have what we have and we have to work with it. Okay, so thank you very much for your attention and see you with some part of you today on labs.
Sir?
Yes.
You wanted me to send you an email about additional lists.
Okay.
But I didn't, so I wanted to remind you about this list.
But if you have you sent me the email?
No, I didn't. I was supposed to do it today, or yesterday. So should I still do it, or it's enough to just remind myself?
I have to answer to it. Okay.
Okay.
I forget. I need a break to eat something. Okay, then I will fight with your colleagues on the lab. I remember that the idea, but send me the email. Okay.
Okay. Yeah, I will. Okay. Okay. Thank you.
Thank you.
Goodbye.
Goodbye.
Goodbye.